Okay, this is ratio test number 2. And now we're actually going to be looking at some that have factorials in them. Now the ones with factorials are a little trickier. You just have to realize a couple of things. So that's the limit as n goes to infinity of -1 to the n plus 1 times n plus 1 squared times 2 to the n plus 1 over n plus 1 factorial times n factorial over n squared times 2 to the n. So that's the limit as n goes to infinity of, oops, I lost my -1. My -1 should go to the bottom. -1 to the n plus 1. Okay, so I've got -1 to the n plus 1 times -1 to the 1 times n plus 1 squared times 2 to the n times 2 to the 1 times n factorial over. Now, n plus 1 factorial, let's talk about that for a second. Remember that factorial, if I had 4 factorial, this is an aside, that would be 4 times 3 times 2 times 1. If I had 3 factorial, that would be 3 times 2 times 1. So if I had 4 factorial over 3 factorial, that would just leave 4, because I could write 4 factorial as 4 times 3 factorial, and they would cancel. I'm going to use that same concept over here. N plus 1 factorial is really just n plus 1 times n factorial. And then this is -1 to the n plus 1 times n squared times 2 to the n. Let's see what cancels here. 2 to the n. N factorial. Anything else? Oh, -1 to the n plus 1. And I'm looking, and that's all I see. Okay, so that's the limit as n goes to infinity of -1 times n plus 1 squared times 2 over n plus 1 times n squared. Now, if I multiply all this out, I'm not going to take the time to multiply it all. Well, yeah, why not? Nah. Yeah, I will. Okay. That'll be, and because this is an absolute value, the -1 is obsolete. It doesn't matter. And I could actually pull the 2 completely to the front. So it'd be 2, the limit, as n goes to infinity, because anytime there's a constant, you can pull it to the front, of n squared plus 2n plus 1 over, that'd be n cubed plus n squared. The bottom is bigger than the top, limit automatically goes to 0. 0 is always less than 1, so because 0 is less than 1, it converges, because what you're trying to find is where is it, if it's less than 1, it converges. If it's greater than 1, it diverges. And remember, if it's equal to 1, it's you know nothing and you need to do another test. You shouldn't have used the ratio test to begin with. Alright, last one is, I'll tell you what, let's take it to a new page so it's not all cluttery. Okay, the limit as n goes to infinity of 2 to the k plus 1 over k plus 1 factorial times k factorial over 2 to the k. Well, I'm going to rewrite that. I made it really big. That's the limit as n goes to infinity of 2 to the k times 2 to the 1 over k plus 1 times k factorial times k factorial over 2 to the k. 2 to the k's cancel. K factorials cancel. And I essentially just have the limit as n goes to infinity of 2 over k plus 1. Well, the degree of the bottom is bigger than the degree of the top, so it goes to 0. 0 is less than 1, so it converges. Alright, that's it for the ratio test.